Ever felt the ground shake, even just a tiny bit? Or wondered how massive mountain ranges like the Himalayas got so high? The answer lies deep beneath your feet. Our planet isn't a solid, static ball of rock. It's alive. Its surface is broken into enormous pieces called tectonic plates, and they are constantly on the move. This is the incredible story of plate tectonics, the engine that drives our world. Imagine the Earth's outer layer, the lithosphere. It's cool, rigid, and fractured into about a dozen major plates. These plates aren't just floating aimlessly. They're surfing on a hotter, gooier layer called the asthenosphere. Think of it like giant rafts drifting on a thick, slow-moving sea of molten rock. This movement isn't random. It's driven by immense heat escaping from the Earth's core, creating powerful currents in the mantle that push and pull the plates above. There are three main ways these plates interact, creating all the drama on the Earth's surface. First, we have divergent boundaries, where plates pull apart. As they separate, molten rock, or magma, rises from the mantle to fill the gap. It cools and solidifies, creating brand new crust. This is happening right now, deep under the ocean, at places like the Mid-Atlantic Ridge. It's literally stretching the ocean floor wider inch by inch every year. Then, we have the opposite, convergent boundaries. This is where the real action happens. When two plates collide, something has to give. If a dense oceanic plate crashes into a lighter continental plate, the oceanic plate gets forced downward, diving back into the mantle in a process called subduction. This is a destructive force, creating deep ocean trenches, triggering massive earthquakes, and melting rock that fuels explosive volcanoes, forming chains like the Ring of Fire around the Pacific Ocean. When two continents collide, neither one wants to sink. Instead, they crumple and buckle, pushing rock upwards to form colossal mountain ranges. This is exactly how the Himalayas were born, as the Indian plate continues to crash into the Eurasian plate. The third type is the transform boundary, where plates don't collide or separate but slide horizontally past one another. The motion isn't smooth. The plates lock together, building up incredible stress over decades or centuries. When the stress is finally released, it sends powerful seismic waves through the crust. We call this an earthquake. The San Andreas Fault in California is a famous example of this kind of boundary, where the Pacific plate is grinding northwards past the North American plate. So how do we know all this is happening? The evidence is all around us. It started with a simple observation. The coastlines of continents like South America and Africa look like they could fit together like a giant jigsaw puzzle. Scientists then found identical fossils of ancient plants and land animals on continents now separated by vast oceans. There was no way these creatures could have swum across. The only explanation was that the continents were once connected. Even more convincing evidence comes from the ocean floor. As new crust forms at mid-ocean ridges, the Earth's magnetic field gets recorded in the rocks. Since the magnetic poles have flipped back and forth throughout history, this creates a perfectly symmetrical pattern of magnetic stripes on either side of the ridges. It's like a barcode that proves the seafloor is spreading. And if you map out the world's earthquakes and volcanoes, you'll see they're not random. They form clear lines that perfectly trace the edges of the tectonic plates. This constant motion is not just about destruction and creation. It's part of a grand recycling system called the rock cycle. Old crust is destroyed in subduction zones, while new crust is born at divergent boundaries. The intense pressure and heat from plate collisions transform existing rocks into new types, a process called metamorphism. Plate tectonics controls where we find valuable resources like metals and oil, and it even influences our climate. The position of continents affects ocean currents, which distribute heat around the globe. It shapes habitats and drives the evolution of life itself. Looking at other planets puts our home into perspective. Mars and Venus don't have active plate tectonics like Earth. Their surfaces are ancient and relatively static. Earth's dynamic geology is what makes it so unique. Plate tectonics is the pulse of our planet. It's a slow but relentless force that has shaped every mountain, every ocean, and every continent. It's the reason our world is constantly changing, a living, breathing geological masterpiece. Thanks for watching, and if you enjoyed this journey into the Earth, don't forget to like and subscribe for more adventures.